Okay, so tomorrow's lesson is on the circle equation and how we could locate a circle on the coordinate plane and how we could read what characteristics the circle has by looking at it on the coordinate plane. Let's consider that a circle has a center point at the origin of the x and y axis. Oh, that's not where I wanted it to be. Let's try that again. Okay, that's better. So the center point of that circle would be 0, 0. So we'll write C 0, 0. Let's also say that the radius that we want is going to be, just need to pick a better color here. Let's say the radius is going to be 5 units. You're going to see why 5 units is the best, because basically it boils down to the fact that we can use a 3, 4, 5 right triangle to demonstrate this. You'll see when I start drawing the triangles. So if the radius is 5, that means everywhere from that origin you can count out 5 boxes. So let's use the pointer for this. Oh, there we go. Here's the pointer. So 1, 2, 3, 4, 5. We're going to have a point right out there. So I'll put 1. There's going to be a point up top here. 1, 2, 3, 4, 5 as well. So let's put 1 up there. 5 to the left, and then 5 down. Now, if you consider that we have right triangles all over this coordinate plane, and we could draw them from the origin, that means if I draw one leg of 3 and one leg of 4, I could pretty much go like this and draw another radius of 5 of that circle. So let me draw that out so you see it. I would go 4 this way, and then 3 up. That would make a right triangle, and that point right here would be part of that circle. The same would go for this one. Just get my lightsaber. If I start here and I go 1, 2, 3, 1, 2, 3, 4, there should be another point right there. Same would go for the opposite side. If I go 1, 2, 3, 1, 2, 3, 4, there'll be a point there. And if I go 4 this way and 3 that way, I'll have another point. So 1, 2, 3, 1, 2, 3, 4. Oh, I don't like that one. So I fixed that one and added another one that is 1, 2, 3, 4, 1, 2, 3. I should do the same thing going down. 3 this way, 4 that. Oh, sorry. 4 this way, 3 that way, and then 3, and then 4. And on the other side, same thing. 4 down 3, or 3 down 4. So those are all the points that we would need pretty much to sketch a circle. So let me do that. I'll sketch a little circle. I'll use red. I'm going to try to be very careful with this. That was supposed to be red, but I'm going with blue because I don't feel like changing it. And it goes all the way around. So that's what my circle looks like if I was to draw it all the way around, the origin at 0, 0 and a radius of 5. Now, how does this affect the equation of a circle? Well, remember before when I drew that triangle. Let me try this again. Use red this time. If I drew the triangle that this point right here makes, I have there, there, and there. There's your right triangle. If you wanted to know what the radius of the circle would be, it would be the length of the hypotenuse of that right triangle. So, if we use the Pythagorean Theorem, that would mean the radius is equal to whatever the x value is squared plus whatever the y value is but since it's the Pythagorean Theorem, we'd also have to consider the fact that the r is being squared too. And that's basically how the circle centered at the origin equation looks, only we usually write it as x squared plus y squared equals the radius squared.